Okay, this is probably going to be a pretty short video, but we need to talk about acid-base indicators to talk about when we do titrations, which is the next topic. How do we know when the titration is over? How do we know when to stop? Okay, so an acid-base indicator is pretty much any molecule that changes color with pH. Let's see if I can try to fix that. Cule. That changes color with pH. Okay, there are lots of them. Honestly, you can make one yourself if you feel like it. If you go to the store and you buy a red cabbage and you cut it all, chop it all up and boil it, the liquid that's going to be at the bottom is a really good acid-base indicator. It changes color like 8 times between pH of 0 and 14. Not all acid-base indicators necessarily come from naturally occurring plant sources, but they're not uncommon. Okay, they are typically organic molecules. Okay, they also are typically actually weak acids or bases. But they are weak acids or bases. So it has the potential of actually altering your pH, but honestly, we use very, very small amounts, usually just like a few drops. Okay, so we use them in small enough volumes to not alter the pH. This is something that will probably never occur in any lab setting for you, but it is possible that if you have low enough concentrations of acid and base that this can actually affect things. In most lab settings, the concentration of the acid or base that you're titrating has a high enough concentration that this isn't going to affect much. Okay. Let's look at just a couple examples to get the gist of how this works. The most common one, the one that you guys have seen in lab probably, is phenolphthalein. Misspell this. Phenolphthalein. Okay. It's an organic molecule. And essentially what happens is it is clear under acidic conditions. So if you have it in pH of neutral or acidic, it's going to be completely clear. You wouldn't even know it was in there as far as appearance. But it turns a very bright pink when it gets to basic conditions. This is super useful if you're doing a titration. If you have an acid as your starting stuff and you put the indicator in there, it'll be clear, and then as you drip base into it, it will turn pink when it gets to, well, around neutral. Technically, the change occurs at a pH of 8, not 7. But in the next video, we will see why that's not really a big deal. It works out either way. Okay. Another example is something called Phenol Red. I know we've got 2 in a row that say phenol in them. It's actually pretty common. So Phenol Red under acidic conditions is yellow. Under neutral conditions is orange, and under basic conditions is red. Here's the problem. This isn't real precise. It's a subtle change from yellow to orange to red. Basically you'll know when you're near neutral. This is not good for titrations, but it doesn't mean it's not useful. Okay, so this version is less precise. Honestly, a lot of times indicators are picked on where the color change occurs. The color change usually occurs around the pKa of the weak acid or the pKb of the weak base. So if you need something to change at neutral, phenolphthalein is great. If you need something to change at like a pKa of, or a pH of like 3, you're going to need to find something that has a pKa of around 3. Okay, so I guess I should write that down. So the color changes at the pKa of the indicator. If it's a base, it would be pKb, but we're going to stick with pKa for right now. So there are hundreds of indicators out there. I do not need you to sit around memorizing them. Honestly, if you're doing a simple strong acid, strong base titration, phenolphthalein is the go-to answer. But there are definitely situations where other indicators are more appropriate. Okay. We probably shouldn't also overlook the idea of pH paper. pH paper is literally just a strip of, it's essentially the same material as like filter paper, and it's soaked in 2 different indicators. And the way it works is if you have a pH less than 4.5, it's going to be red. Okay, if you have a pH between 4.5 and 8, it's going to be kind of yellows to greens. And obviously you guys have seen this in lab and it's kind of gradation, but that's okay. If you have a pH greater than 8, it's going to be a shade of blue. So this is not super precise. It's usually precise to like plus or minus 1 pH unit. But if you're just trying to do a quick test, like, okay, this is an acid or it's a base, this is really, really useful. Okay. All right. Like I said, quick video. All right. Thank you.